Hey, and welcome to this module in our titration video series. We're going to be covering container enforcement, specifically containers running on top of Kubernetes. So, we've all heard about this Kubernetes thing, this container thing, and I'm sure if you're looking into it in your environment, you're starting to think, well, what exactly can I do to control what those application developers are doing? I'm fine if they want to containerize their applications. That's no problem to me. In fact, I understand why they might want to do that. But at the same time, I can't just turn it into a wild, wild west. I'm going to actually need to keep the same level of control that I had on my bare metal servers and my virtual machines extended into my Kubernetes clusters. And that's what we're going to look at today, which is how you can take the policies that you would enforce on your bare metals and your virtual machines and enforce those same policies in Kubernetes in a native way. Sound exciting?
Sounds super exciting.
Sounds like the future, right?
Sounds like you're putting all marketing buzzwords inside one sentence.
We can play buzzword bingo in this session, indeed.
Let's go. Machine learning, data lake.
I'll try sneak all of those words in for sure. So, when we're talking about Kubernetes integration, there's two major bits of components that we need to connect to. We want to connect to the API of Kubernetes to pull metadata about the workloads that are running on top of it. And we also want to pull information via the software agent, and most importantly, push policies down via that software agent. So to get started with the policy enforcement in Kubernetes with titration, it's actually not that difficult, right? And we configured the external orchestrator in our module on external orchestrators to connect our titration cluster to our Kubernetes cluster.
Sounds easy so far. Do you need an agent as well, maybe?
We do need an agent. So we can see here that we have successfully connected the external orchestrator. We're not going to have some detail on that, and we can move straight over to our software agents. So if we look at our software agents here, we will see that we have installed the enforcement agent on our Kubernetes nodes. Node 5, Node 4, Node 3. And if we look into that node, we'll actually be able to see some annotations that have been applied to it. Those annotations are extracted via the Kubernetes API. This is not information that we've put in manually as an end user, but it's actually been extracted automatically.
Just a quick question that actually, I know we've covered some stuff in other modules of this series. Is it a different agent for containers?
No, it is exactly the same agent that you would install on that operating system as if it was just a vanilla operating system that wasn't going to be running containers. There is nothing special that you need to install.
That's pretty cool.
Yeah, so in this case, we're using Ubuntu. And in fact, we used the installer script, so we didn't have to do anything difficult to get that agent installed. And if you want to know some more information about how you would install an agent via the installer script or via the RPM package or the MSI package, do check out the module in installing and deploying agents. So we have our container node here. And if we click user annotations, we'll see all of these annotations, a lot of annotations actually there. And
lots of hexadecimal strings and stuff like that. Seems interesting.
You know, the further we go into the future, the more UUIDs I seem to see. But what's interesting is all of this is very, very detailed metadata about this Kubernetes node, right? We can see the fact that it is a Kubernetes node, that it's a machine. That's the type of workload that it is. We know information about the version of Docker that's running, the version of Kubelet that's running. We know it's on a Linux machine, and we know some information about, for example, the pods that might actually be able to run on that node. So it's a very, very detailed information at the node level that we extract via the Kubernetes API.
Pretty impressive.
Yeah.
And is there anything we actually need in all that, or?
Well, need is interesting because we can always use this metadata in many different ways. So you don't have to use this information, but you could later on use it for doing things like identifying the nodes and which ones you would like to apply certain software agent configuration profiles on. And you can also use it for creating scopes, some of this information. Let's say that you would like to build a software agent configuration profile to apply some specific configuration to just Kubernetes nodes, but you want to be able to scale it as and when that cluster grows. So by using, for example, the workload type machine and using the Kubernetes cluster name, you could actually identify all of the workloads. Here we see the cluster name right there in a dynamic way, right? If that node or if that cluster grows, we'll automatically apply the right software agent configuration.
Okay, so your recommendation is pick some important attributes like cluster name, machine type, that kind of things, and use that to actually feed your annotation. So don't get too hung up over all the other options in there.
Yeah, this is just fantastic for visibility purposes.
Okay.
So as we know, in Kubernetes, there are the nodes, which are the actual hosts of those containers, and then there are obviously services that run on top of Kubernetes. That would be pods and actual Kubernetes services. And those are the things that we're really going to want to control the connectivity between. So we've got our nodes connected, we've got the software agent installed, we have the external orchestrator configured. Let's get down to actually looking at the types of policies that we can design, how we design those policies, and finally what the enforcement looks like.
That sounds good. Maybe just a word of clarification. In the current version, Tim, my understanding is that we actually support enforcement in containers, not visibility. Is that correct?
That's correct. When I use the word visibility in the case of containers, what I'm talking about is annotations on the workloads, whether that is the node or the pod or the service. But we are not talking about flow visibility. Inside Kubernetes, there's a couple of different reasons why flow visibility is not always possible, and sometimes it doesn't even make sense to get flow visibility inside a cluster. So for the purposes of titration, our integration with Kubernetes is all about extending your policy enforcement capabilities into that Kubernetes cluster.
And for clarity, we're in version 3.3. Just in case
Yes.
someone watches this video series far down the line.
Yeah, and 3.3 of titration as well.
Exactly.
Because we're on 1 point something of Kubernetes, so if we were on 3.3, that would be definitely in the future somewhere.
Absolutely.
So we have actually deployed an application on top of Kubernetes for this part of our demonstration. So we have our core banking application, which is a traditional application that's deployed on top of virtual machines. And we have our data lake application, which is new, shiny, full of buzzwords and bingo like that. So we've deployed that on top of Kubernetes.
You actually managed to put that word in an application name.
Yes, right into the name
I
of the
see.
application.
Well done, Tim, well done.
And just because it's deployed on top of Kubernetes doesn't mean that it should have any less security controls applied to it. We should be able to apply the same security controls that we could do on a VM on our pods.
I'm curious to see when we get there, how do you plan on handling Kubernetes talking to the core banking app? Because I'm fine with Kube and shiny objects and so on, fancy, all easy. Again, we were at RSA, we see everyone can enforce around containers. That's great. How do you bridge the gap?
Yeah, that's really it. And I think that's the problem that a lot of organizations are struggling with right now, which is Kubernetes is new, it's shiny, it solves a lot of problems for the application team, but it creates a huge number of problems for the security team, for the networking team, and the infrastructure team, because their traditional security tools simply don't work inside Kubernetes. On the other hand, you can't just switch to a brand new set of security tools overnight that just support Kubernetes. There's no way that you're going to switch off all of your legacy applications, or you're never going to migrate some applications to Kubernetes. So whatever you're looking at to secure your data center and your enterprise, it has to be able to deal with both the legacy and the modern types of applications that you have available to you.
So you're basically saying, I can go from AIX through SUSE running on Z down to a container and then somewhere in AWS.
Correct. And you can describe that entire end-to-end policy in that one single pane of glass integration.
That is cool.
Yep. That really is.
That's just pretty cool.
That is really damn cool.
I'm with you.
Let's take a look at what we have deployed and the kind of policies that we can write. So we actually have our application here on Kubernetes. So we can see our pods.
You like your CLI, huh?
We like our CLI still. The CLI is never going to die. So here I have selected the pods that are part of this application. So I can see, there's an importer pod where we're going to pull in data from external systems. We have an executor, and we have a number of different pipelines which are going to process that data in some way. Big data, another buzzword there.
Did you put, I don't see GPU optimized machine learning instances there yet?
I ran out of time, unfortunately, but tomorrow, that's what's going to be there.
Oh, great, thank you.
So we have our application. It's made up of typical Kubernetes constructs. If you're not familiar with those, don't worry, but as you start to deal with Kubernetes, you'll become very used to hearing the word pods and services. They're the two main constructs that you would be able to wrap policy around. So we have pods, which are really where the workloads are running, And we have services that are somewhat like load balancers that sit in front of the pods and control access to those individual endpoints inside the pod.
Maybe just, it's super quick because I know it's not a topic, pod versus container.
Okay, that's another good question. A pod is an entity that could have one or more containers inside it. So in many circumstances, a container equals a pod, but it is possible for there to be many containers in a pod. And the real thing is that they all share the same namespace. So containers inside the same pod have complete access to each other, and there is nothing that's stopping them from talking to each other. But when a pod speaks to another pod, they must control their communication, and that is two separate entities talking to each other. Anything else to add to that?
No, I think that's pretty correct on that. Maybe last topic, Docker versus Creo and all that stuff.
Okay.
What do we support on Titration? It's really clear.
So Docker versus Kubernetes, obviously Docker being the runtime of those containers, and Kubernetes being the orchestrator that deals with pushing those containers there and removing, adding them, and orchestrating the entire thing. Now, we support Docker as the runtime today. There are some other runtimes out there, and some which are gaining more popularity, and while we support Docker only today, we will be continuing to look at different runtimes as and when it becomes important for us to support them as well.
I think for support, as usual, cisco.com/go/titration, you'll have all the details of what's currently supported at the moment you're viewing this video.
Yes. So
okay, show us, Tim.
We have our pod, and we also have some services that sit in front of our pod. This allows us to control the ingress to a set of pods, because it might be that there is one or more pods that are actually part of that particular service. If you want to horizontally scale in Kubernetes, you just increase the number of pods behind a particular service.
Okay.
Make sense?
Up to now, it's okay.
Cool. So let's come back to our cluster, and we can actually look at the policies that we have created. So if we come to applications, just like how we've been dealing with policies from our existing applications, from our core banking prod application, we have the same screen available to us here, but in this case, we're operating on a scope that is defined by the Kubernetes cluster.
Okay. So just scope, same scope as before. You can go and check the scope module for all details in there. Just we restricted this scope to the Kubernetes environment based on the annotation that you showed us at the beginning of this video.
Yes, okay. We were able to dynamically lock down the workloads that are part of this application due to those annotations being imported into the system.
Okay. And as you said, there is no visibility, so you don't run ADM on containers. I mean, it doesn't make a lot of sense, but you don't plan to run ADM on containers, right?
No, you wouldn't really want to be running ADM on containers, because as you're moving applications to a containerized environment, it makes sense to actually reassess exactly what and what shouldn't be there. So in many circumstances, the developers will actually go through and rationalize the policies themselves. And there's often a lot of policies that are built in a programmatic way in a containerized environment.
Sure, and we can import policies right from manifest files or stuff like that.
Yeah, absolutely.
Okay.
You can import them via the API, or you could even use things like CI/CD pipelines to dynamically push policies into Titration as you update your builds.
Perfect. So actually, it's very flexible, and that's the reason why we don't need ADM in the context of containers. But if I take ADM on the rest of my network, and the rest of my network is actually talking to a container, I will still see this flow.
Yes,
is that right?
That's right.
Okay.
Awesome. So we have some policies in place here. We have some policies referring to pods. We have some policies referring to a service. And I can also see the banking web provider there as well.
Okay.
So let's walk through these, and then maybe you could visualize those for me on the board afterwards as well.
Sure.
So we have the data importer pod. This data importer pod is defined based on a query. This query being a dynamic query using the pod name. This is pulled from the attributes that Kubernetes knows about those workloads.
So that's the external orchestrator integration, right?
Yes.
Okay.
By having that external orchestrator information, I can select workloads based on their identity in Kubernetes.
Okay, very nice.
That's incredibly important, for example, in the Kubernetes world, because pods often spin up and spin down. It's part of the typical and expected life cycle of a pod to go up and go down. Especially if you're dealing with elastic applications that scale up and scale down, pods have a very short lifetime. So you need to be referring to policies based on metadata, not based on IP addresses.
Yeah, I mean, that makes total sense in the world of containers.
Yeah. Now, we're talking about the world of containers, and that's an interesting comment. While those pods are in the world of containers, banking web on the right-hand side here, if you remember from our module on application dependency mapping and policy enforcement, banking web is actually part of the core prod banking application.
You're right, now I remember. Isn't that actually the application we were giving Bob access to in the campus module?
Yeah, in the campus module, we allowed Bob to access banking web via his authenticated status, and we also created banking web as a provided service, which allows external applications to talk to this banking web tier.
Makes sense.
And that's why I can actually create that policy. I'm saying I would like the banking importer to be able to speak to banking web over port 443.
Okay, makes sense.
It looks not so exciting, but what I actually did there was join two completely separate worlds. I referred to an object inside a Kubernetes cluster accessing a VM on my vCenter that is totally outside of that Kubernetes cluster, yet I was able to securely write that policy in the same way as if I'm talking about objects inside the container world.
Honestly, again, very cool.
Yeah, really reduces that complexity and the amount of headaches that you have when you're dealing with these new flashy containers.
Just to clarify as well, the enforcement practices there, if my understanding is right, not only do we merge and blend the two worlds together, we're actually setting policies on the banking website and on the container side to access the container. So it's not as if you're just like, oh yeah, sure, you're aware of the outside. No, the actual containers interact with the rest of the environment.
Yeah.
And that's true defense in depth.
It's defense in depth, and it's a real end-to-end policy.
That's really nice.
Now, we've also got some further policies in our environment here. We have the executor pod, which is reading the data that's been pulled by that importer, and it's pushing it through a number of different pipelines.
Okay.
Now, the executor pod, again, we've referred to that based on the pod name.
That's
simple
good.
enough. But for the services, for the pipeline services, here we're actually referring to Kubernetes services. That's a native construct inside Kubernetes that lets you define effectively a load balancer that sits in front of one or more pods. So here, I didn't actually have to specify the pod name or the IPs of the pod, but I just say I want to access the service provided by all of those pods that make up the deduplication pipeline, the sort pipeline, the merge pipeline. So if I look at that here, I get to build a policy based on the service name that I've defined inside Kubernetes.
So let me get that right. So you're talking about containers here, so pods that are connecting to something which you don't really know what's behind it yet.
Yep.
And you're relying for that on native constructs of Kubernetes to actually, for kube to tell you, hey, you know what, actually this service is actually these sets of IPs.
Yeah.
And all that is done transparently for you behind the scene. Whatever number of services behind, whatever number of pods are behind these services, everything is automatic.
Yes. Automatic, and it's constantly refreshing. As and when things change, we're updating everything dynamically. What's really cool about this is that the actual application developer that really wants to get started with Kubernetes, they can use all of the learning resources out there to understand Kubernetes. They don't need to do anything different than if they weren't to have your security controls applied to them. Yet, at the same time, you can wrap that security around those pods, around those services, and use those native constructs inside Tetration. So I think, again, that's really cool.
Yeah, I would agree with you, 100%.
So we've got this out here. And then the next thing that we obviously want to do is enforce these policies. Is it going to be tricky?
I mean, hard to say at this point. I mean, you're using a service name, so I don't know. I hope it will work.
Yeah, so actually in the background, there is quite a lot that's going to have to go on to just enforce these four policies. We're talking about traffic outside a Kubernetes cluster, talking to a pod inside a Kubernetes cluster. We're talking about pods talking to services that we don't necessarily know the IPs of. There's a lot of stuff that needs to be automated and orchestrated. But from our perspective, let's go and see what it looks like to enforce policies.
Sure. Hit enforce, and we should maybe describe the flow of traffic between each of them.
In fact, I've enforced the very latest version of these policies, so I can't even update the policy enforcement, and I have that in place already, so we can see that those policies are being enforced.
That's even better.
Yeah.
So can you just clarify the audience what you managed to enforce, but actually you never needed to make any changes back to the policy again? Is that because you're using filters?
Yeah. So because I've enforced that policy based on a filter which is dynamically updating, every 60 seconds it's reevaluating who matches that criteria. Everything is going to be handled in the background for you.
So what you're telling me there, if I got that understanding right, is that I will design my policy in Kubernetes based on filters. And actually, you're again designing your intent. But unlike ADM, you're actually designing your intent in a way which you actually never need to go back and touch it.
Yeah.
Once your intent is set, it doesn't change. Developers match tags and they can do whatever they want.
Yeah.
That's why you didn't change this policy.
Yeah, no need
Cool.
to change it. Okay, so what we have is enforce this policy, and perhaps we could then, either we can take a look at what those policies look like on the pod itself, on those workloads, and then we can visualize that on the board. How about that?
We can do that.
Okay, so we've enforced those policies, and I'm going to take a look at this executor pod. So the executor pod here, we know should be able to speak to the pipeline service, the dedupe service, the sort pipeline, and the merge pipeline.
Okay.
So if I come to my Kubernetes cluster, right now I'm at the node level. I'm outside the individual pod. And at this point, I'm going to see the IP table rules that are applied to the node itself. A lot of IP table rules applied to the node. You'll see some of them referring to titration, some of them referring to Calico, and that's because we are using Calico as the networking plugin. And that's a lot of policies at the node level, right?
That's quite a few. And there's another thing that just struck me. We're using Calico.
Yes.
Does that mean that Calico is the only supported CNI we can use?
It's actually the opposite. We can support nearly every single CNI out there, and that's because we enforce policy in a CNI independent way. CNI being the container networking interface here, the plugins that let you choose between a number of different networking objects that are available. So Calico is supported, but any CNI that doesn't masquerade IPs, which any CNI that actually follows the CNI protocol shouldn't be masquerading IPs, it's going to be supported by titration for policy enforcement.
Great. So my personal favorite, Cilium, will work.
Yes, absolutely.
Flannel, Weave.
All of them. Right now, today.
That's pretty cool. And even the CNI, which have more adherence with solutions, like for example, the ACI CNI, which integrates deeper inside ACI, would that work?
Yep.
Cool. So I have no dependency there. I can choose my CNI. I can apply my CNI here, and I can even leave the Kubernetes guys make all the decisions they want there without any restrictions.
Yeah, no restrictions at all. And that's what's really nice. If your application developers have already gone ahead and started embracing Kubernetes and containers, they've got their cluster up and they're using a particular networking plugin. Let's say that networking plugin doesn't support all of the native network policy constructs that you might be able to use with other products. Well, that's no problem with titration. You're not going to ask them to rip and replace their networking plugin, which can be a very controversial ask. You'll be able to go and start applying policy enforcement into any environment that the developers have ready, even if they're using a networking plugin that doesn't support native Kubernetes policy enforcement. Sound good?
That's nice. So I can also have in my environment 3 kube clusters, 3 different CNIs, and same enforcement.
Correct. Yep. So here we have the policies on the node. Let's actually look at a policy on an individual pod. So we're going to look at our pods. We wanted to look at the executor pod. So
before you go there, can you also list the services IPs so we just have them for reference?
Yep. So we have the dedupe service, the merge service, and the sort service.
Okay.
So now let's enter into the actual container itself. So we'll go into the executor and we'll get a shell. Now we can execute IP tables and we'll see the difference. Boom.
Yeah, that seems a different policy.
That is a different policy. And the reason being is that every pod is in a separate network namespace and therefore gets a completely different set of optimized policies that only relate to that pod and that pod only. Yeah?
That's cool. Can you show us the members as well of the service endpoints?
Yeah, for sure. So we can see that these are the service endpoints here, 34,000, 32,000. And if we pull up one of these, for example, we will say, here we can see that service there.
24.4, does so sort?
Yep.
So you put a name in the UI. So all the UI has been constructed based on kube constructs. You put names inside it. The iteration went down, and through external orchestration, understood everything and how things are supposed to flow. And now, with this flow done, it will actually basically piece the whole thing together.
Yep. So that's talking about a pod interacting with a service inside the Kubernetes cluster. How about we go onto the importer, for example, and look about the policy where it's referring to the core banking web application?
Yeah, sure.
So we can do the same and get our pods up, and we'll look at one of our importers. Here we go, we'll choose this one. Jump into that pod, and we'll again execute IP
I see
tables.
you have very lightweight containers, by the way. I mean,
Yeah.
IP tables, IP sets.
Yeah. Running everything, and here we can see the same. We can see that there is a set of policies, a different set of policies. Even though they're on the same node, we have different policies on a per namespace basis.
That's what I was thinking. We said the same is actually not at all the same. It's actually it's 33,000, 34,
Yeah.
30. What was the other one? 32.
Yeah.
So we have two pods, two total different IP namespaces, and two completely different set of policy for one sensor on one host.
You got it.
That's neat.
Yeah, it is. And if we don't want to look at these via the IP tables output, which you know I like CLI, but we can also look at the UI.
Yes.
These container policies are also going to be visible to us on the node itself. So let's say, for example, I come to one of my nodes that's running these workloads. Let's pick node 5. If you are running containers, you will see that you have container policies available for you up here, and you can see information about the actual container pods and the policies that are related to those containers, including, for example, seeing the fact that they may access the titration system itself, and that they may access services inside the system. So here I can see that pod executor is able to access that service.
So I can see the rule rendered down. So again, back to our module, we were talking about enforcement. We actually render to a concrete set of rules the intent, and that's what we see here, including containers.
Including containers. And if you have noticed just a few seconds ago, not only are we referring to the policies that relate to that containerized application, but we've also included the policies that apply to everyone globally. If you watch our module on policy ordering and hierarchy, you'll understand how that you can use global policies to enforce baselines of rules that are applied to every application, like you may speak to titration, or you may speak to our DNS servers, or you must allow yourself to be scanned by our scanning systems. Those policies are extended into the pods inside Kubernetes and are also applied to them as well. So you as the admins can still have control over applications in Kubernetes in the same way as you would on a traditional application.
That's neat. The
Yeah.
whole thing is pretty neat.
Yeah.
Cool.
So why don't we just go over that one more time on the whiteboard, just so that everyone's comfortable with the concepts around what we're doing with container enforcement.
Sure. Taking a few colors because I think we need a few colors.
Yes.
So a few things, first of all. Let me get that right. This here is actually my kube environment, right?
Right.
This is something else.
Yes.
Could be cloud, could be on-prem, could be anything. I don't care.
Yep.
Okay. So in the workflow we have here, we have a connection that's basically database importer is going to connect. I see it's a consumer talking to a provider, so it's going to connect up to the core banking app over port 443. It's going to do some kind of magic thing, put files on some form of shared storage system, and then it's going to be able to use the executor, which will pick up files in there, and those files are going to be sent to the merge, which here is a service, and sort is a service, and dedupe is a service. Those are pods, so you could have 1, 2, 3, whatever number of pods inside each of those. Very perfect square.
That looks like
you
a
must
square.
enjoy it. So here and here.
Yep.
And those ones were merged.
Merge is 34,000.
34,000.
Sort is 32,000.
32.
And dedupe is 33.
33,000. So we have this topology there. behind merge, I could have any number of containers or any number of pods, right?
Yeah, that's the thing. The service is defined as the entry point to that part of the pipeline, but it needs to be scalable, right? It might be that as more data comes in, we scale out that sorting pipeline, and then when it's not necessary to be sorting so much data, we scale it back down again. But from the application developer's perspective, I just get to refer to one service endpoint when I'm talking about it in my code.
So that's pretty sweet. So I mean, the developer, because obviously we could talk about the great world of microservices.
Yep.
Another word, tick box.
Yep.
In this world, I may not have control on who's actually merging those services, who's sorting, who's deduping. And what you're saying is that, hey, if we are two different teams and we don't need to speak together, you come to me and say, if you want to access my service, you have to use service name equals merge.
Yep.
And then how I manage the backend, my problem. That's really, really useful, I think.
Yeah.
So that comes down to one question to me when I see all that. And okay, it's interesting. You're using the native services inside Kubernetes, which is okay for sort of basic applications. Can you handle different kind of LLB, like for example, Citrix or Avi or F5 in the context of containers?
Yeah, that's true. So in this example, we're talking about a service which is represented by a cluster IP. Typically, they would be services inside the Kubernetes cluster. But you will, at some point, want to actually advertise a part of your application to external entities. And at that point, you might either use something like a node port, which is typically used in a dev or testing environment, or if you want to be in production, you might use something like an ingress controller. Now, Tetration allows you to deal with both node ports and ingress controllers in the policy natively. If you use a node port, we're going to build the policies and wire everything up based on that dynamic port that is allocated. But most interestingly, like you said, if you're using an ingress controller and that ingress controller is the type of a F5 load balancer, a Citrix load balancer, or an Avi load balancer, Tetration's actually going to be able to talk to that load balancer and dynamically push policies down to it via that ingress controller object.
So that's pretty cool. So what you're saying is that if I take third-party devices, which have different set of features and so on, which are managed by different vendors, and I decide to plug them into my infra because I want better security, I want better end-to-end kind of solution, Tetration will take care of the orchestration of the policy only, inside those elements.
Yes.
And are you saying the policy is actually going to the ADC device, or is the policy going anywhere else?
So the policy is going to go to the ADC. So if you saw our session or our module on the different places that you can enforce policy, sometimes when you're talking about policy coming into a Kubernetes cluster, it makes sense to enforce it on that ADC because that's the most scalable place to just clean that traffic and make sure it's the right type of data that's coming into the application. So it's actually taking command and control of the policies on those load balancers dynamically for you.
That's neat. But then that yields a question. Does that mean my config is more complicated? Like, how do I define a service in this case?
It's exactly the same way that you would define it as if it's just a vanilla service as well.
So you tell me if tomorrow my kubeadmin comes in, he says, you know what, Citrix, best thing ever. I'm going to go and deploy Citrix. And he decides to deploy Citrix. He can then just turn on the integration with Tetration, and there would be zero changes to policies, and they would actually get rendered on Citrix directly.
Yes, you've got it.
Wow. Lots of flexibility there. So you can choose your Kubernetes world, Kubernetes or OpenShift. You can choose your distribution, Ubuntu, CentOS, whatever you want. You have your Docker layer that's there. You can choose your CNI. You can choose your ADC device. And all that, you can have the exact same policy orchestrated across any world, whatever you choose, however you decide to mix them.
Yep, and don't forget that you can control that policy either through a user interface, single pane of glass, via the API, or pushing it through CI/CD pipelines as well. So you have that total flexibility to control everything in that new Kubernetes world.
That is amazing.
Yeah. I'm very excited to see this.
Definitely.
Yeah.
Is this beta software, by the way, or has it been out for a while?
So this has actually been out for over a year, and this is generally available software that's in use in many environments.
That's good. That's really amazing.
Yeah. I do think that this is very cool. Well, Thank you for joining us in this session on containers and Kubernetes enforcement. I really hope that was useful for you. If you'd like any more information on Tetration or containers with Tetration, please visit cisco.com/go/Tetration.